In this video, I'm going to have a look at using the Excel function that comes with FlowZF to carry out a design of experiment where we extract values for various parameters from an Excel spreadsheet and insert them into our sequence, our optimized sequence, and thereby optimize the measurement sequence. To do that, I'm going to talk about this optimized sequence that I've built already, and specifically I'm going to be drawing out commands from the Excel pseudo device and including them and describing them in this work sequence. So what we're going to do here is we're going to open up an Excel spreadsheet and then read various values out of that spreadsheet, and those values are then going to be inserted into the actual sequence that is repeated for each replicate. For example, selecting a port and pumping fluid, aspirating fluid, dispensing it to the detector, mixing it, and so on, and processing the data. And then at the end of the measurement, the result is put back into the Excel spreadsheet, and we can draw graphs from that data. So if we execute the sequence as it's working, I'll describe the various features that are being used. This is the Excel spreadsheet that is created, and this spreadsheet contains a section over here where various experimental conditions are set up, and the way that I do it is I typically keep all the conditions the same except one of the parameters I vary, and those parameters that are being varied are highlighted in blue. So each one of these lines is a single measurement. As the sequence begins by reading all of these values into the sequence, and then we move on into executing the actual sequence. So you can see here the red bar indicates where we are in the sequence, and if you have a look at the steps in the sequence, you'll see here flow pro valve, go to port, and then it's port Z2. Port Z2 is a value that it read out of this spreadsheet. In the Excel spreadsheet, I've created an experiment name that gives all the values that are used in this particular measurement, so that when we look at the results table, we can see what are the specific values for each of the parameters. The results are then placed in this area over here. We can do up to 3 replicates of each set of conditions, and then the average is plotted in these graphs over here. These graphs I've set up to correspond to the settings over here on the x-axis and the results on the y-axis, and so you can see that as each data is obtained, the graph is updated. At the start of the experiment, we set here which specific sets of conditions we want to execute. So I said start at row 11 and end at row 47. That tells it that there are going to be 27 measurements carried out, and I've told it to measure each result in duplicate. This red bar over here indicates which set of conditions it is busy with at this stage, and as it gets the result for the second experiment, you'll see this graph over here will change in real time. Here's the profile is just busy finishing off, and there's the second piece of data that has been obtained, shown in the chart. We of course don't need to execute all the measurements in this table. You can say, well, we want to just have a look at this parameter over here, and once this parameter has been optimized, then use the optimized value in all further experiments. Then you would start the sequence again, and it would create a new Excel spreadsheet that would execute the experiments, or provide the data for the experiments for the next set of values. And then once you've got a table that has all of your optimized values in it, you can do as I'm doing now, run the optimization from the first experiment down to the last one, and in that case results for all of the charts will be given. This particular chart is having a look at sample volume, so the impact of sample volume. As we increase the sample volume, as should be expected, we'll get an increase in sensitivity. If we go and have a look at where these various files are, in the data folders folder, you'll see that there's an H2O2 master, and that's basically a blank spreadsheet like this, and it allows you to set up your initial set of conditions. That is then copied with all of those conditions into the H2O2 parameters Excel spreadsheet, and it becomes kind of a submaster. And from this submaster, in the optimize folder, you'll get an H2O2 plus the date plus optimization 1. And when we run this again, it will increment that to optimization 2, and so on, so that for a particular day's optimizations, we have Excel spreadsheets for each of the optimizations that are carried out. You can see here that it continues to add data to the to this graph as the results are obtained. And this information is now also stored in our results table here. Here you can see the conditions in the name field. You can see the conditions that pertain. In the track, you can go and have a look at any particular data point and scale it to suit yourself. And the actual peak heights are recorded here. You can also see during the run itself, the data as they are acquired are shown in the glow cell manual control. Also see the pump moving in whichever direction it is moving, and the valve control shows you which port is selected on the selection valve. So by running this whole sequence through, we'll get a set of conditions that is optimum by looking at each of these highlighted sections to see which result gave us the best sensitivity. Or in the case of this set of experiments here, we're having a look at the impact of flow rate on precision, and so you can go and calculate the precision, the RSD of the results obtained, and see which set of flow rates gives you the best precision. This set of conditions over here allows you to see whether the order of used for the aspiration of reagents and sample, which order gives you the best results. The one case we've got analyte, reagent, analyte, and the other one reagent, analyte, reagent, and whichever order gives you the best results, that's how you will set it up in your final sequence. So with this optimize functionality, what that allows you to do is to set up a set of parameters in a spreadsheet, read those parameters into a sequence, and then obtain results for that parameter set, and thereby optimize the measurement sequence. Of course, you could do this manually, but by automating it in this fashion, you do a systematic evaluation of each of the parameters that affects the method.